Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
Today, we will be talking about short circuit. So what's a short circuit? A short circuit is basically a branch in a circuit with zero or no resistance. And as we all know, anytime there's a short in a circuit, all the current in that circuit will try as much as possible to pass through the short because there will be nothing there to prevent it from moving. Any current in a circuit, always look for the least resistant parts. So anytime there is a short in a circuit, there will be no current flowing through all resistors parallel with this short. So anytime a resistor is in parallel with a short, that resistor will have its current being zero. In other words, when we can traverse across the short and the resistor without coming across any other component, then the resistor is short-circuited. I think we can understand this thing in very well if we visualize it. So let's consider this circuit. Let's call this one V, this one R1, this R2, and this R3. Remember our definition for short circuits. Now, when you consider only R1 and you want to traverse across R1 and this short, this is the short. Sorry, let me take black. This is the short. This is the short. This wire here. So if you consider the short and only R1 and you want to traverse across it, you will see that you will come across R2. So you will be confused as we've come across another component in the circuit. But per our definition, if we can traverse across the short and then the resistor without coming across any other component, that's when they are in parallel, then we can say the resistor is indeed shorted. But here, when we consider R1 and R2 together, we can go across them without coming across any other components. Then we can say the short is in parallel with R1 and R2. Or we can traverse across R1 and R2 without coming across any other component. Remember, the short is just a wire. So when we traverse across R1 and R2 like this, we don't meet any other component, which means R1 and R2 are in parallel. So let's redraw this circuit, simplify it, and find the total resistance R1, R2. Let's call that resistance R1, 2. You will see that value will be in parallel with the short, which means no current will pass through them because the current will look for the least resistant part, and then that will be the short, since the short has zero resistance. I hope I'm being clear enough. So let's draw another circuit. Sorry, this is my V, and this is my R1, 2. And this is my R3. Now we can clearly see that this short circuit here, is in parallel with R1, 2, which means this resistance value will go to 0. And you can also see that this short here is also in parallel with this R3, which means that one will also go to 0. So in effect, all the resistors in this circuit will go to 0. No current will pass through them. So when there's current from the voltage source, it will just come and pass through the short, because that's the least resistant part. The least resistant part. So nothing will go here. Yeah. If this is not clear enough, don't bother yourself. We'll take another example. Yeah. So let's see. Let's consider this circuit. So something simple like this. This is my short. Something like this. So let's call this our V, the voltage source, a DC source, of course. Here is, let's see, here is 4. This is 1. This is 2. This is 3. This is 3.5. Sorry. This is 5. And this is 7. Sorry for my handwriting, guys. Yeah. This is our short. Yes. But what is it shorting? What resistance value will this thing render 0? So we now check what component here is in parallel with this short circuit. And to find this, we have to check if we can traverse across these components without coming across any other components. And of course we can. So see, let me change my pencil. We can see that this 5 and 7 are connected in parallel. Since they are in parallel, we can find the total resistance. So yeah, when you find the total resistance, you will get something like, yeah, I can't do that thing right now, but it will be 5 times 7 over 5 plus 7. So we will redraw this circuit, the simplified version. So we will get 5 times 7 is 35, and then 5 plus 7 is 12. We just simplify that one. That will be total resistance. When you find that resistance value will be in series with the 3.5, and that resultant will be in parallel with the short circuit, which means all the resistors here will have no current flowing through them. So in effect, we remove them from the circuit. So the circuit can become something like this. The red part is off. This is our circuit. Do you get it? This is our circuit. Because this and this are in parallel, and they are in series with this, and then they are in parallel with the short. You see? So this part will go off. It's actually there. I'm not saying it will go off as if it's not part of the circuit. I'm only saying that no current will flow through it. When the current is coming and then it reaches here, it will choose this part over this part, because this part has least resistance. You get it? Yeah. So now what we can do is we find the other values, that resistors which are short circuited. Now we can see that this resistor here is in parallel with this resistor, because we can traverse across them without coming across any other components. Yeah. So we can find the total resistance of them also, and then that one too will be in parallel with this one. You see, it being in parallel with this one, and that one will also be in series with the remaining one. Yeah. And that's it. They are not shorted. They will have, if they have current flowing through them. When there's a current coming from this side, it will split. Some will pass here, some will pass here, some will pass here. Yeah, that's it. These shorts only affect this side. I hope you get my explanation very well. Yeah. Thank you very much for your time.